Good afternoon, all you young geographers out there, and a warm word of welcome to our second telematics broadcast. Now, I know that by now you should have completed your March control test, and I hope that all of you were well prepared. Therefore, just in order to do your best, it's always a good thing to prepare yourself as early as possible, even if it's during March for a control test. Now, this afternoon, we are going to have a discussion of geomorphology. Now, the past few years, geomorphology was very poorly answered in the examinations. But if you stay with me, and if you concentrate on what we are doing here this afternoon, we definitely will make geomorphology a bit more easy for you and see if we can get to the highest possible mark that you can get at the end of the year. Now, before we continue, it's very important that you must know that when you're working with geomorphology, it must always be integrated with your topographic maps. And for that reason, I've got quite a few maps that we are going to share with you this afternoon. And I just want you to also not only listen to the facts that we are going to try to explain to you this afternoon, but also look at the links between the first question paper and the second question paper. Now, during the third quarter, we will return for only a map work session. And then, of course, some of the slides that I show you today, we will also have available for you when we do our map book. Okay, so without further ado, let's have a look what we are going to discuss this afternoon. We are going to have a look at stream patterns, stream orders, longitudinal and cross profiles, fluvial landforms, stream piracy, and rejuvenation. Now, obviously, we won't be able to cover all our geomorphology this afternoon in the short time that we've got available, but I can promise you that the most important things we will definitely have a look at. We are also going to have a look at a few of last year's question papers, and perhaps have a look at the few mistakes that some of the students have made. Okay, so we are going to start off with stream patterns. People, now, what you must know about stream patterns, let's first have a look at all our stream patterns that we've got here. The first one that we've got is our dendritic stream pattern. I think I'll put all of them on: the trellis, the radial, and the rectangular. These are the most important of the stream patterns. But I would like to start actually by the last block that we've got here in red. You must know the following of stream patterns. Firstly, of course, you must know the name. You must know what it looks like. You must be able to give a description of the stream pattern. And very important, you must also be able to discuss the underlying structures that have caused the specific stream pattern. Now, people, this is very, very important, especially for your second question paper as well. And therefore, I will also show you a few photos as well as topo maps with regard to stream patterns. Okay, let's have a look. Remember, these are the three things that you must know. Let's start off with the dendritic one. Now, if you have a look at the dendritic one, this would be the dendritic stream pattern. You'll see it looks like a tree. Now, it's very, very important that you must know that for this shape to occur, you must have uniform rocks. Now, what does uniform mean? It means that the rocks are basically about the same. You know, when you are at school, you've got on your school uniform, you all look about the same. And so the rocks that we've got here, uniform rocks. So that's our first one, the dendritic one. Now, the second one, the trellis, what's very important that you must know here, this is what your trellis looks like. Here you've got alternating layers of hard and soft rock. So what happens is that you've got your stream that will flow where you've got your soft rock, and your hard rock will be your little hills or mountains that will be found between your streams like that. That's the trellis one. Now, people, I must say that people usually sometimes confuse the trellis with the rectangular one. Please, people, what's very important with the rectangular stream pattern, two things with regard to 90 degrees. Remember, rectangular has to do with 90 degrees. But people, sometimes most of you only remember the fact that the tributaries join at 90 degrees. Remember that it also makes 90 degrees bends. Have a look at that one. 90 degree bends, and look at the tributary joining at 90 degrees. What does it look like? The underlying structure is when we have joints and faults underlying and what happens is that these streams then flow within these joints and faults. The radial one, that's the easiest one of the lot. That is when you've got a butte, a conical hill, or a little mountain, and then what happens is that all these streams just flow away from the central point, from the central highest point, causing the radial stream pattern. Now, people, what's very important, as I've mentioned in my introduction, is that you must be able to identify and describe and answer certain questions in your second question paper as well. So you must know. Let us have a look at here. We've got the dendritic one. You see it's in the shape of a tree. There we go. Okay. Here we've got the trellis one. What's the trellis one? Alternating layers of hard and soft rock. Let's have a look at that. There we've got brown, and here we've got brown. Here we've got brown. That will be my hard rock, and in between there our streams are flowing there, so that would be the softer rock there. And then we've got, of course, our short tributaries flowing from the mountains and joining up with the main streams there. Here we've got a Google Earth photo of a rectangular one. This is a beautiful photo. Have a look at that. Here we've got, look at the cracks that we've got here. And what we've got here is, there we've got our river flowing there. Beautiful, look at the bend, 90-degree bend here. And here we've got the tributary joining also at 90 degrees. Okay, now have a look at this one. Now here we've got the radial one. Here we've got a high point here, a high point. And here we see that the radial drainage pattern, stream patterns, we see that they are actually radiating away from the highest point that we've got here. Okay, so people, these are your different stream patterns that we've got here. Very important, people. You must be able to recognize them from diagrams on your topographic map. Very, very important, people. And also, please don't forget, you must be able to describe the underlying structures at the bottom, that have caused these different types of stream patterns. Okay, so these are the stream patterns that we've just had to look at. The following thing that we would like to have a look at is drainage density. Now, if you have a look at drainage density, people, and immediately this diagram, we've got here a high drainage density. Look at all the rivers here, right, with the tributaries. So we've got a high drainage density there, and just compare to this one here at the bottom. Immediately you see there's a huge difference between the two here. But now the question is why? Why have we got a high drainage density there, and why do we have a low drainage density here? People, you must be able to answer that question in the exams. Please, let us have a look at that. Okay, now if we have a look at this, we will see that this area here, the lighter shaded area here, this area has a higher rainfall. Of course, higher rainfall. That's why we've got more rivers there. Hard rocks. Now, why hard rocks? Got hard rocks so the water can't drain through and the water actually remains on the surface of the earth. Steep slopes, less vegetation, and I've already mentioned less infiltration. So that is why we have a high drainage density in that area. Now, if we look at the one below here, of course, people, just have a look at the two. You only need to study the one, because the other one is just exactly the opposite. Have a look at this. The high density, there's my reasons. Low density, here's my reasons. Exactly the opposite. Look at that. High rainfall, of course, lower rainfall, because you have far less streams. Hard rocks, soft rocks. Steep slopes, gentle slopes. Less vegetation, lots of vegetation. Less infiltration, more infiltration. So people, this is very, very easy. Okay, so see that you are in the position that you can identify your high drainage density and a low drainage density, and of course give reasons why do we have a high density density in certain area, and at another area a lower drainage density. Okay, so that is a drainage density. Right. Now, people, the next thing that sometimes causes problems is your stream orders. Now, people, you've got to stay with me now, because we've picked up these things in the exams that people really don't know how stream orders work. Now, please, people, before you can understand stream orders, there are two concepts that you must know. The first one, which is source, and the second one, confluence. Now, the source, people, of course, that's very easy. That's where the river starts, in the mountain, right on top. That would be the source of the river. Now, confluence, people, that is where one river flows into another river. And if you don't know what these two and how these two work, then it's going to be very difficult for you to actually understand stream orders. Now, okay, let's have a look at our stream orders. The first thing that you can recognize here, people, is that first order streams are like fingertips. Now, I want you to, if you look at your fingertips, hold your hand here in front of you, and now I'm telling you that your first order streams are like fingertips. Now, okay, here we've got 1, 1, 1, 1, 1, so your first order streams will be like that. Okay, now let's have a look at our diagram, at our map here, and immediately you'll see that it's exactly what it looks like. Yeah, and it's very important, people, that you must know, just as the tip of your fingers, exactly those ones would be your first order streams. And you would see your first order streams are right at the source at the of the drainage basin, and very important, your first order streams have no tributaries. Okay, they are the first order streams that we've got here. Now, okay, the second order streams, people, where you get a confluence. Now, I see somebody asked me again here, what is a confluence? Now, very important, people, I'm glad that you asked me that question, because if you don't understand confluence, what a confluence is, you won't understand the second stream order. Because a confluence, people, if you've got a river and another river joins that river, that place where they join, we call that a confluence. Okay, so what's going to happen now? We have seen now where we find our first order streams. Remember, I showed you on your fingertips, all the four. Now, they are going to join somewhere. And as they join, we call that the confluence, where these two, where the one flows into the other one. And where a first order stream flows into another one, joins another first order stream, there we will get a second order stream. Okay, back to our map. Now, if you have a look at our map here, and immediately you will see this. Here we've got the first order stream becoming a second order stream. You see how easy is that, right? A first order stream at the confluence, becoming a second order stream. Exactly everywhere. First order stream, confluence, after the confluence, second order stream. Okay, so this is what you've got. Now, the question is now, what happens if two second order streams, if they join? Exactly the same, of course. Your second order streams, if they join, will go over and become a third order stream. Let's have a look at this. Here we've got a second order stream and another second order stream. Here we've got the confluence here. And of course, after the confluence, that will be a third order stream. Have a look at this here. I've got all my first order streams around here. Here I've got the first order stream becoming a first order, another first order stream. There's the confluence, becomes a second order stream. Exactly the same here. First order stream becoming a second order stream. And now these two join each other and they become a third order stream. Now it becomes easy. Third order stream coming this way, another third order stream there, and of course, then that would become a fourth order stream. Now, people, all you have to understand is this. It's what they call in geography, the geography mathematics, not geography mathematics. And you'll see now why we call it the geography mathematics. Because a 1 plus a 1 gives you a 2, a first order stream, and a first order stream gives you a second order stream. And that is where the mathematics actually stops. Because a 2 plus a 2 gives you a 3. Second order stream plus a second order stream gives a third order stream. Have you got that? Third order stream plus a first order stream gives you it remains a third order. And now this is now a very important thing coming through here. In other words, if you've got a third order stream and it's been joined by a first order stream, then the highest order stream goes through. Okay, so this means it remains a third order stream. There we go, another one. Third plus 2, second order, remains a third. But let's see what's happening now. A 3 plus a 3 gives you a 4. Then it starts again. 4 plus a 1 gives you a 4, and so forth, until we get a 4 plus a 4, fourth order that gives you a fifth order. So people, that is what you've got to understand when it comes to stream order. So please, people, have a look at your source, have a look at your confluence. Those are the things that you must look for. Okay, at your source, what must I look for? Lift up my hand. I've got my fingertips. All the ones, the first order source will be there. Am I right? Okay, first order stream, first order stream, here it will come your second order stream. Have you got that? 2 second order streams, third order streams, and so forth and so forth. Okay, people. So this would be your stream orders. Please expect a question of your with regard to stream orders in both your first question paper and your second question paper. Remember, this can't be studied, people. Right? You must practice this. You must understand this, because this is application. Okay, as I've said, both for your first and your second question paper. Okay, now people, now we are going to have a look at the discharge of a river. And when we have a look at the discharge of a river, it's very important that you must have a look at 2 types of discharge. We've got laminar flow on the one side and turbulent flow on the other side. Now, what you must know is you must know the difference between your laminar flow and your turbulent flow. And you must know why do we get it, and the process that the processes that we get in these type of flows. Now, let me just get this thing started here. So, if you have a look at this, people, then immediately you will see that on the one side we've got the water flows as parallel sheets. Have a look at that, beautiful parallel sheets. But look at this, very turbulent, the water is flowing on the side. Why is it flowing parallel sheets? Because the river bed right at the bottom will be even. And if you look at this one, immediately you must know that the river bed on this side will be uneven. And of course, just look at the way the 2 of these rivers flow. Of course, there will be more erosion on this side by your turbulent flow than in your laminar flow. So people, please, you must know the difference between laminar flow and turbulent flow. Now, last year in the exams, they asked a question with regard to laminar and turbulent flow, which I would like to share with you. It was a more short type of question. Now, people, I would like to tell that just as in our previous ones, as soon as you see this icon, you must know we're busy with an exam question. Right, now, the question was as follows. Study the figure below. Indicate whether each of the following statements refer to turbulent or laminar flow in a river. Now, here we've got the diagram. And here we can see our turbulent flow there, and here we can see the laminar flow here. And I hope you've made a mental note of the images that you've seen in the previous slides. I purposely put the 2 next to each other so that you can see the difference between the 2. Now, all you had to do in this question is they made a few statements on this side, and all you had to say is it laminar or is it turbulent? It's as easy as that. Have a look at that. Associated with the riverbeds that's level and even, of course, there, it would be laminar, if you've listened to our discussion. Okay, associated with irregular swirling flow, you know, the turbulent flow, turbulent. Now look, so easy is this. Effective in eroding, of course it would be turbulent. Commonly occurs in the upper course of the river. We're coming back to the upper course, just hang on with that so long. That would be turbulent. The water flows in thin layers. Remember the video clip that we showed you. Laminar, associated with higher river velocity, which also be laminar. Occurs where rapids are visible in the river's course. Of course, that will be turbulent. And as a larger stream load capacity, that would be laminar. Now, people, you see that all these things, you must be able to have a look at the characteristics of laminar and turbulent flow. And then this question was a walk in the park. In fact, this was one of the questions that was quite well answered last year. But then you must know the difference between laminar and turbulent flow. Okay, now, people, now we're going on to very, very important work. We are going to have a look at longitudinal and cross profiles. Longitudinal and cross profiles. Now, it's very, very important, people. You've got to listen to what I've got to say now. These 2, they usually ask as definitions of concepts in the exams. You must know what is a longitudinal profile, and you must know what is a cross profile. Very important. Now, here I've got the definition. Is the side view of a river from source to mouth. Now, people, I just want to show you what happened in the exams last year. This question they actually asked in the exam. What students would write, learners would write is, it's a river from source to mouth. You won't get any marks there. Or they would say, it's a side view of a river. People, you must give the full definition of this concept. Is the side view of a river from source to mouth. You can't only say the side view of a river. There are many side views that you can have. You also can't say a river from source to mouth. it must be a side view of the river. So please, people, take note, very, very important that you must know how to answer or define your concepts here. Now, what's very important, there's the source, there's the mouth, and what did we say? A longitudinal profile runs from the source to the mouth, and because it's very high here, because it's very steep, here you're going to have your fast flowing, your turbulent. Can you remember in our previous discussion of laminar and turbulent? Here you're going to have your turbulent flow. Here you're going to have less turbulence. Here you're going to have more your laminar type of flow. Okay, why? Because it's very gradual and it's slow moving. Okay, so please remember, people, you must know your longitudinal and cross profiles. Now, what is a cross or a transverse profile, people? That is the shape of the river valley from one bank to the opposite bank. So if here's a river and you are standing on the one side and your friend is standing on the other side, and you can draw a profile from where you are standing from the one bank through the river to your friend on the other side, that would be your cross section of the river. So please, people, please, they usually ask these very important definitions. Okay, see that you're in a position to define your longitudinal profile, and please, people, I want a perfect definition. Okay, not half of the information that you're not going to get the marks. Actually, the cross profile is much easier to define. But please, when it comes to the longitudinal profile, see that you give the real definition as accurately as possible. Okay, so now, people, what's very important is that we are going to have a look at the longitudinal profile of a river. Now, if you have a look at the longitudinal profile, you must know that a river you find you've got three courses: the upper course, the middle course, and the lower course. And this river runs then here from the mountains right through to the sea. Now, okay, let's have a look at the characteristics of these courses.
The course of a river comprises of three distinct parts. First is the upper or the mountain course, where the river originates. Here, the velocity of the water is faster due to the steep gradient. The floor of the valley is narrow and the valleys are V-shaped. Second is the middle or the valley course, where floors are wider and the sides of the valley are more gently sloping. Here, the velocity of the river is slower than the upper stage. Meanders are typical landforms found in this stage of the river. The third part of the river is the lower course, which has a gentle slope and is almost flat. The river channel is usually at its widest and deepest here, because the amount of water flowing within the river is at its greatest.
Okay, now about 15 minutes ago, somebody asked me a question here. I see it here on the computer. What is a meander? I purposely didn't ask that question because I wanted to come to this slide where I could answer it very well, much better. Now, if you have a look at this picture here, the meander is just nothing else than a bend in the river, okay? Where the river flows straight, that's fine, but as soon as you've got a bend in the river, then that is called a meander. Okay, a meander is a river bend. Okay, right, let's have a look. Now, what happened now, people? We showed you a video clip of longitudinal and cross profiles. Let's just see what have they said. What was this video clip all about? It had to do with the three parts: the upper course, the middle course, and the lower course. Now let's have a look at this. The first thing is the upper course, right? The upper course is steep. It's fast flowing, downward erosion, and there we usually get our waterfalls, rapids, and interlocking spurs. Now what I'm doing now, people, I'm just summarizing what was said in the video clip. And then the middle course the cross profile would look something like this, from the one river bank to the other river bank. Okay, right. Now the second one would be our middle course. Now you look at the middle course. Of course, the slope is much more gradual. It will be a slower flow. And what happens now, just look at the difference. Here we get downward erosion. Here we get lateral or sideways erosion. because in the first stage here in the upper course, it was blocked in here by the mountain and couldn't go sideways. And now as the river exits the mountain here, immediately the erosion can move sideways as well. So we've got lateral erosion there. And of course, here we've also got your meanders that we've got here. Have a look at the meanders. Of course, if you can remember, you would know that your meander is nothing else than an ordinary river bend. And then, of course, we've also got our spurs there. Now, please, people, remember that the spur is a high-lying area between two rivers, okay? A spur is a high-lying area between rivers. Not like somebody in the exams where they asked what was a spur. So this student wrote that a spur is people with a taste for life. So please, people, see that you give the correct geographical definitions when they ask you to do so. Okay, so that would be the middle course. The last one, this would be the cross section. I'm coming back to the cross section now again. This would be the lower course. Now your lower course is almost flat. Have a look at that, right? And the water flows, because it's very flat, the water flows very, very slowly. And you're going to have deposition here. Have a look at here. Here we had downward erosion. Here we had lateral or erosion towards the side. And here we have deposition. You must know the processes, people. Okay? And what will we find here? Oxbow lakes, deltas, meanders, marshes, braided streams, and sandbanks. I'm coming back to that again later on during the course of the afternoon. And this, people, is what the cross profile will look like. Now, what I want to show you now is have a look at this cross profile here. And this one in the middle course. And that one in the lower course. And people, what you must notice is the following: that if you look at the cross profile in the upper course, then the V of the valley shaped valley would be very narrow. Okay, have a look at that. As it goes to the middle course, then the V opens up a little bit. And if you have a look at the lower course, then the cross profile would actually be at its widest there. So please remember these things. It all has to do here with the fact that you've got lateral erosion towards the side. That's why it's getting broader. And here is much slower. And this channel of the river is getting broader and broader all the time. So people, if I must just quickly summarize what we've done now with regard to longitudinal and cross profiles, and I would definitely suggest that you do something like this, people. Take your, have a look at your textbook, have a look at your notes, and see if you can summarize your longitudinal and cross profiles like this. People, if you know this, there are very few questions that you cannot answer. Have a look at this. Here we've got the cross profile. That is what it looks like in the upper course. That's what it looks like in the middle course. That is what it looks like in the lower course. Have a look at the features and the processes that we've got here. The features, it's very steep there, right? And because it's steep, it flows faster. And that is why we've got downward erosion. You see the link between the three there. Here again, look at this. Look at the link. Gradual slope. It flows slower. And now we've got our lateral erosion. Look at this again. Also the three things. It's almost totally flat there. The river is flowing very, very slowly. And because it flows slowly, it cannot transport the material. And we get the material that will be deposited there in the lower course. Now, if you have a look at the landforms that we find in your different courses, in your upper course, we find your waterfalls, rapids, and spurs, right? Here we also find in the middle course, the river will start to meander or bend. And here we'll find the spurs. Here we'll find sandbanks, marshes, braided stream, and here we've got the oxbow lake, right? And that's very important, people. You must also know that here we'll get our turbulent flow, and down here we will get our laminar flow. Your question came through here on a steep slope. Why don't we find a laminar flow? There we've answered the question to you. The slope is very steep, and what happens is the water runs off very fastly, and you get this turbulent movement of the water. Okay, so this, people, have a look at the summary again here. And what you must do, actually I want to give you some homework tonight. If you haven't done something, you haven't got something like that in your book yet, go and summarize your longitudinal and cross profiles. Very, very important that you must be in a position to have a look at that. So people, that is your longitudinal and cross profiles. But as I've said in our, when I started off the session, I said that your topo maps are very important. Okay, so let's have a look of these different courses in what it looks like in on a topographic map. Here's the upper course, or the Young River, as it's also known. Now have a look at this. Immediately you see lots of brown here. Now in the upper course, of course, look, the contours are very close to each other. In other words, it will be steep. And because it's steep, it's going to be fast flowing. Because it's fast flowing, downward erosion. And they see how close these contours are to each other. So you can expect your waterfalls, your rapids, because your contours are close to each other. It's very steep, and those are the landforms that you will find there. So please, people, remember, you must be in a position to identify a river in what course ever. Remember, a very popular question in the exams is they give you a topographic map and they ask you, in what course is the river? Give a reason for your answer. There's it. Okay, so that's the upper course. Let's see what it looks like in the middle course. Here we've got the middle course, or the mature river that we've got here. Here we've got the Eerste Rivier running here. What's very important, the first thing that you notice is that it has exited the mountain. Okay, we don't see any high mountains here. Actually, it's much more gradual. Look at the contours. If you must compare it with the previous one, look at all the brown there. See how close the contours are to each other here. And immediately, if you go down to the mature river, there you see immediately the first thing that you notice is that it's much more gradual. In fact, look at all the farming activities that we find along the river. It's a nice valley that we've got here. Lateral erosion is becoming wider. Again, have a look at the rivers here, and immediately you only see it's in a very thin pencil line. That is how the rivers have been drawn in there. And compared to that, immediately the rivers are a bit wider, and immediately you also notice that this river is starting to develop river bends that way, and your meanders that are formed there. Okay, have a look at your lower course. And if you look at your lower course, the first thing you notice here is, here's no contours, right? This means this whole area is level, as I've been, written here, so right across the map here. So this area is very level. The mouth of the river, have a look at that. There's the sea, it's the mouth. Marshes that we've got here, all right? Look at the broad floodplain. See, the river is even broader here as well in comparison with the previous one. Here we've got huge meanders here and even braided streams, sandbanks. Why have we got sandbanks here? Because the river is flowing so slow that is the sand is being deposited here. So you must, people, be in a position, this is very important, that the thing that I'm telling you now. You must be in a position to identify your upper course, the middle course, and the lower course on your topographic map. Okay. Now, people, something that we had a huge problem in last year's exams was river grading. Now, have a look at this. You must know the difference between an ungraded profile and a graded river profile. Now, have a look at these things here, and this is very, very, very important that you have a look at this. Here we've got an ungraded river profile. What is an ungraded profile? An ungraded profile is a profile where temporary bases of erosion are found. Now, what are temporary bases of erosion? These are things like a waterfall, a lake, even rapids, dams. These are your temporary bases of erosion. Then it's an ungraded profile. But when these temporary, remember this one that you're seeing here is exactly the same as this one. It's the same river, in fact. So what's happening now is, if you have a look at this river, the same river, over a period of thousands of years, all these temporary bases of erosion have been removed, and now you've got a smooth concave profile. In other words, in this one, the waterfall and the lake has been removed here. So people, when you have a look at grading a graded river, the reason why people can't answer these questions is because they don't know the difference between a graded river and an ungraded river. People, please, you must know that. Your ungraded river, that's your river with your temporary basis of erosion, in other words, your waterfalls, your rapids, or lake that you find in the river, right? With your graded profile, all those things have been removed, and you've got a smooth concave profile of your river. Okay, now let's have a look at the question that was asked last year. Now, last year this following question has been asked. The figure below shows a longitudinal profile. Draw a labeled freehand sketch of a graded profile. Here they're giving you an ungraded profile. Now, why is this an ungraded profile? Of course, here we see a rapid. Here we see a waterfall. So, sorry. So this is definitely an ungraded profile. Now they're asking you to draw a labeled freehand sketch of a graded profile. Now, Matric, when we had the discussion of our climatology about a month and a half ago, I said a very important thing. I told you that remember that in the exams, they are going to ask you to draw certain things. If you can lay your hand on the supplementary exams that was written now a few weeks ago, you will definitely see that these questions are also repeated there. Anything can be asked, especially when it's a simple diagram, right? And the examiners love to ask you to draw this. Now, let's go back to our diagram here. Here we see we've got a longitudinal profile. This longitudinal profile is ungraded. Have a look at that. I've got rapids there and a waterfall. So when this graded changes to a graded profile, then this must happen. In other words, all these temporary erosion, bases of erosion must be removed, and then I'll have something like that. Okay, and this is the way in which it was marked as well. Here we've got the source. Here we've got the mouth. Right, that would be the labels that you had to supply there. You would have, it was a 3-mark question, 1 mark for the source, 1 mark for the mouth, and if you had the correct shape, in other words, if you had your shape that was correct there, then of course you would have your full marks for that question. So have a look at that, people. Have a look at the difference between the two diagrams, and if you can really notice all these things, people, you will see how easy this really can become. Okay, now the next question was the problem one. Also dealt with graded profiles. Have a look at this. This was a paragraph type questions, and you know, paragraph type questions, people, we have huge problems with you guys when it comes to paragraph type questions. That really these questions are poorly answered. You've got to start practicing your paragraph type questions. Now, have a look at this. Look at these questions. In a paragraph of approximately 8 lines, explain the processes, and I've put that in red, that the profile must undergo to change from an ungraded to a graded profile. Have a look at this. Here we've got the ungraded profile, am I right? This is the graded profile, the one that the students had to draw. So now, the previous question was that you had to draw the ungraded, the graded profile. Now, in a paragraph, you have to say, but what must happen for the changes to take place? But what are they asking? They are asking the processes that the profile must undergo, the processes. Now, let's have a look at what the memorandum looked like. Now, what I did here was the processes I've highlighted in red, that you can see what happened. Downward erosion. Remember, to have to remove all those things, here in the upper and the middle course, you must have downward erosion. Then this means that the slope is going to become steeper in the upper course. Have a look at that. Headward erosion will remove the temporary basis of erosion. Now, hang on with headward erosion. I'm coming back to headward erosion again when we do stream piracy. The waterfalls retreat. In other words, it moves backwards. It moves stream up. Hang on to that as well. I'm coming back to that as well later on. Rapids that will be flattened or removed. If there are lakes, the lakes will be filled up. Increase stream carrying capacity, because these things must be eroded, be removed. The gradient in the lower course must decrease. In other words, it must become more gentle. Steep there and gentle there. Have you got that? Stream discharge in the lower course must reduce, and deposition must take place here. Deposition, very important. These things that have been removed here, all this, the material must go down there. It must be deposited there. Then you get a gentle gradient, and that, people, is how this thing changes into that. Very important that you must know the processes when it comes to your graded and your ungraded profiles. Okay, this was a difficult question. please that you understand, see that you understand that you can answer these type of questions. Very definitely a high order question, difficult question. You have to think all the time while you answer that question. Okay, people, now we are going to have a look at fluvial landforms. Now, of course, we cannot do all the landforms, but we are going to try to do the most of them. I am especially going to have a look at meanders and waterfalls because those are your popular questions. Now, if you have a look at your fluvial landforms, people, these are ones that you must know. You must know how oxbow lakes are formed. Don't worry, we're coming to that. Here's your floodplain. Here's our meander again. Here's the braided stream, delta. You must know all of these things. But what's very important, people, is that they can ask you in the exams, what are floodplains? Floodplains are found in the lower course of the river, and they are flat and immediately next to or adjacent to the river. See that you are in a position of answering that question. What is a fluvial floodplain? Okay, now, people, the first thing that I'm going to have a look at will be waterfalls. Now, it's very important that you must know how waterfalls are formed and what happens when you have a waterfall. Now, you must remember that your key when it comes to waterfall is harder rock and softer, less resistant rock. Remember this rock, these ones that are darker ones that I've indicated here. These are very hard. In other words, they are much more resistant. And these ones, the lighter colored ones, that are the softer rocks, they are less resistant. Very, very important that you must know that. Now, okay, now what happens is actually the form of a waterfall is that water comes and actually it falls. That's why they're calling it a waterfall over the harder rock, right? Because the softer rock, what happens is it erodes away much faster. Well, the result is that you get this water, it comes up to your hard rock and it falls actually over the hard rock. And then, of course, we've got your rapids. People just have a look some people call actually a rapid small waterfalls. And if you look at this photo here and you look at this, well, perhaps they're not very wrong when it comes to that. So what happens here, exactly the same at your rapids, the water flows over harder and softer rock. And you've got, what kind of flow is that? Of course, your turbulent flow that we've got here. Now, people, we're going to have a look at waterfalls now, simply because waterfalls are very important. Now, as I've said, when we study waterfalls, people, there are two key things that you must remember. The first thing that you must remember is your harder and your softer rocks. Have you got that? What you've got that? You've got your harder rock on top, and because the softer rock gets eroded much quicker, the water comes and it falls over the harder rock. Okay, that's the first thing. The second thing that you must remember is that waterfalls are not static. They move all the time. And the way they move is that they move back upstream. They retreat upstream. Now, if you remember that one that we did when we did the ungraded profile, one of the ways in which a profile can change from an ungraded to a graded profile is waterfalls that move upstream. Now, I'm going to show you a video clip now, and I want you to definitely have a look and take note of the following. Firstly, the hard rock and the soft rock, and secondly, how a waterfall actually moves upstream. Let's have a look at this.
So we've got windstone, but very important, there's a second rock at high force. And it's the difference in hardness that's crucial in understanding how the waterfall came about.
In this cross-section, the windstone is the darker layer of rock on top. It's so hard that the river can't wear it away. The lighter layer of rock underneath is the softer one that I've just smashed with the hammer. It gets slowly worn away by the water swirling at the base of the falls. It's pretty obvious what's going to happen. And this simple process will of course happen again and again. The end result is that the waterfall actually moves upstream from the spot where it started. As it does so, another landform is created. A gash in the landscape with very steep sides and a river at the bottom. A gorge. And a gorge is exactly what lies immediately downstream from the waterfall at high force.
Okay, so Matrix, very important. I hope that you've caught that on the video clip that we've shown you. Firstly, the harder and the softer rock, and secondly, how the waterfall actually moves upstream. Very important that you had to look at that. Okay, so this concludes our waterfalls. The next one, landform that I would like to have a look at, meanders and oxbow lakes. Now, as I have gone through the lesson this afternoon, many people asked me, what are meanders, what are oxbow lakes? Okay, here we are now with your answers. Now, people have a look at this photo. Beautiful photo. Here we've got our river flowing here, and here we've got our meanders forming here. Meanders are river bends. Please remember that. River bends, not. But when we've got the river bending like that, it does not stay like that all the time. There are certain things that happen. And this is what you must know, people. You must see the relationship between meanders and oxbow lakes. You must know that. If you don't know how meanders work, you will never understand how an oxbow lake is formed. So let's have a look at this and see if we can see how oxbow lakes actually form from out of your meanders.
In flat areas, rivers wander about, forming loops of all shapes and sizes on the valley floor. These are known as meanders. Although they all look different from above, they share the same common features.
As you can see, on the outside of the bend, where the water's moving faster, it's cutting into the landscape, forming that long cliff. But here, on the inside of the bend, where the water's moving much slower, all this stuff is being deposited.
The erosion has left a very small neck on the meander. If we strip the trees away and look at it from above, it's easy to see what will happen next. The fast-moving stream will continue to erode the banks on the outside of the bends. It also erodes the area around the meander's neck. Eventually, the river breaks through, cutting off the meander and forming an oxbow lake.
Okay, people, but when if you know how these things occur, it's very important that you must also have a look at your topographic map. Now, this river running here, this is the Berg River flowing here. Now, see what happens now. The first thing that I'm showing you is that is the direction. Now, here we've got a meander, the river bend, and here we've got one. But have a look at the difference between the two. This is very important. Now, what happens here, people, is that here we get the erosion. And as the bends are eroded towards each other, the neck becomes narrower and narrower and narrower. And eventually, the river cuts through the neck. This river, one of these days, within a few 100,000 years, this river is going to cut through here at the bottom also and run straight through the neck there, as is happening here. And what happens then, people, is that you get that your deposition actually takes place, and then your oxbow lake is actually formed. So those are your oxbow lakes that you've got there. Now, people, what you also must know is what happens with a cross profile around a bend. Now, let's see. Remember, we're busy with meanders. Here's the river flowing now. Here we've got faster flow, and here we've got slower flow. See what's happened. Remember, when you get faster flow, you always get erosion. Slower flow, deposition. Have a look like that. Erosion there and deposition. You can see, look at the amount of stones there and the amount of material here on this side. Immediately you can see the difference. And what's happening there, that is called the undercut, and this is called the slip-off, slope of the two. And if I should draw a cross-section from X to Y, then this is what it would look like. Okay? Have a look at this. Here we've got the deposition that takes place there. Here we've got erosion that takes place here. And this is the undercut slope on this side, and we've got the undercut and the slip-off slope on this side. So this happens actually, it's very easy. So let's just have a look.
At the site of erosion on the outside bend, a steep river cliff is created. The water piles up on the outside bend due to centrifugal force. A bottom current is set up in a corkscrew motion which deposits the eroded material on the inner bank, forming a slip-off slope.
Okay, people, that just summarizes everything that I've actually told you now. Now, people, I want to very quickly have a look at stream piracy, and I hope there's enough time because I'm going to work very fast with you now and have a look at rejuvenation as well. Okay, let's have a look at stream piracy. Now, of course, people, a pirate is somebody that steals. Now, if you have stream piracy, then it means you've got one river stealing something from the other river. And the only thing that it can steal is actually water. Now here we've got a river flowing that way, and we've got another one flowing here. I want you to take note what's happening here. Here, a very important thing that you must know is headward erosion. Going backwards, have a look at this. Here we've got the river, headward erosion. And eventually it joins up with that river. And what happens then is that that river disappears and this river is flowing now in this direction. Remember, the river first did something like that. This river first flowed in this direction. But see what happens now. Because of your stream piracy, this river actually intercepted this river's water, and now we have that. Very important that you must know how it happened there. Now, that would be the elbow of capture. You must know that. That is the captive stream. That is the captured stream, the misfit stream, and the wind gap. You must know these things. You must know every one of these characteristics of your stream piracy. Now, you can have, if you've got, for instance, a town here and another one on this side, yet this town is going to have a lot of disadvantages. Remember, this water has been cut off. So you're going to have water shortage, you've got problems with farming, fishing, recreation, everything's going to be a problem. But on this side, if you've got a other settlement here, what's going to happen immediately is going to have more water available. But remember, it can have flooding. But there'll be lots of fertile soil, farming activities will increase, the economy will boom, and of course the other problem that it can have is erosion as well. So this town here will be much better off than that one after stream piracy has taken place. Now let's have a look at this. Let's see what happened here with stream piracy. These are two rivers. The one is flowing in this direction there, and the other one is flowing in this direction here. But people, this wasn't the case a few thousand years ago. This is what it looked like a few thousand years ago. This river here initially was a tributary of this one here. Have a look at this. Tributary here. Look at the previous one. Then you see, quite different. But this is what it looked like. This was river A, and this is river B here. Now let's see what happened. Remember the first one that we had here. River B, headward erosion. That's the first thing that I must know. That's happening, right? Look at that again. River B, headward erosion there. So see what happens now. This is going to happen now. So this river that initially flowed in this direction and was a tributary there, this river is doing that now. And of course, we've got exactly the same that we've had on the previous one. You must know that this is the elbow of capture. You see, it looks like your elbow. That is the captured stream. Remember, that one was captured. This is the captor stream. This one is the one who did the pirate actually. This is this guy here. This is the misfit stream. It's just a dry piece of stream that's left because of the stream piracy. And this is the wind gap, the dry area that has been left because of stream piracy. People, very quickly, I would just like to have a look at rejuvenation. Very important. We've only got 3 minutes. Rejuvenation, people. If we say rejuvenation, you know, one of the days, especially our young girls around there, within the next, say, 40, 50 years, you will put face cream on. It's called rejuvenation cream. Why? Makes your face look younger. You are still the same age, but it makes you look younger. Rejuvenation, making something younger. Now let's have a look at our river here. What's important is you must know you've got the upper course, the young river, because it flows very fast, just like a man, right? Very fast. Middle course, mature, a bit slower. River is flowing a bit slower. And the lower course, the old river, where the river flows very slowly. But what happens now? What happens is that the river can be rejuvenated. When is the river rejuvenated? When it flows faster and it starts eroding again. Right, now, what happens is how? You must be able to mention the following. Drop in sea level, the land rises, an increase in rainfall, fast-flowing tributary and because of stream piracy. That will increase the river speed and you will get rejuvenation, right? The place where it takes place is called a nick point. That is where the rejuvenation takes place, the nick point, okay? And people, what's very important, you must know the features of rejuvenation, which is a nick point, terraces, and incised meanders. So when you ever look at rejuvenation features, the landforms resulting as a resultant of rejuvenation, it would be the terraces, it would be incised meanders, and it will be your nick point waterfall. See that you are in a position to know how rejuvenation takes place, what is rejuvenation, and of course the features of the landform. Well, people, that brings us to the end of this afternoon's lesson. I hope that we could make geomorphology a bit easier for you. I believe that if you take this DVD again and play it over and over, you definitely will see that geomorphology is easy. So until the next time, bye-bye.